Hey guys, so for 7.3, we're going to be talking about similarity in triangles. So remember before we discussed how to find if two triangles were congruent using things like angle, side angle, side, hypotenuse, leg, etc. Well, now we're going to apply that same idea, but instead of trying to decide if the triangles are congruent, we're going to use things like that to determine if they are similar. So the first one, we're going to apply the third angles theorem. So what that looks like is, if an angle in one triangle is congruent to another, and a second angle is also congruent in another triangle, well, if these two are congruent and these two are congruent, that automatically means that the third has to be congruent, because all angles in a triangle have to have 180. And then this is just to jog your memory on congruent statements. Just remember, if three sides are congruent to three sides, that's side, side, side. Angle, side, angle. Remember, when they share a side, that's the reflexive side. So that's going to be angle, side, angle. This one I have angle, angle, side, angle, angle, side. So you have that. And then here I have side, angle, side, side, angle, side. So this one's going to be side, angle, side. This one is angle, side, side, angle, side, side. Uh-oh, but we can't have angle, side, side. So these would be not congruent. And if they're not congruent, they're obviously not similar. These have, that tells me it's a 90-degree angle, so that means this is a hypotenuse and this is a leg. Hypotenuse, leg. So these are congruent by hypotenuse, leg. And then this, angle, angle, angle. Same thing for your angle, angle, angle. Now before, triangles at all the same angles were not congruent. However, they are going to be similar. So that's angle, angle. Similarity. But they would be not congruent. Okay? So that brings me to this exact thing here. So angle, angle does work for similarity. Because again, if two angles in one triangle are congruent to two angles in another, it means a third angle is also congruent. If three angles are congruent to three angles in another triangle, it means they have the same shape. Which, remember, in order to be similar, they just have to have the same shape, and the sides have to be proportional. Well, if the angles in a triangle are all congruent, it means they have to be proportional. So in this case, are the triangles similar? Yes, by angle. Angle, similarity. Remember, that means congruent. Without the equal sign, it just means similar. Similarity statement, I would say triangle ABC, or in this case, I'm going to use CAB, is similar to FDE. CAB is similar to triangle FDE. Okay, and you could have arranged those in multiple ways. You just have to make sure that they correspond to one another. Notice that C is similar to F, and that A is similar to D, and B is similar to E. Okay. All right. Now for this one. Now this only included angles, but when we have sides involved, we need to know if they're proportional or not. If we have all three angles, then we know it's good, but for triangles. But if we don't have all three angles, then we need to see if the sides are proportional. So in this case, 8 and 2, 8 and 2, and 12 to 3. Well, are those all in fact equal? This is 4, this is 4, this is 4. So yes, they are. Why are the triangles similar? By side similarity. What's the similarity statement going to be? I can go PQR, triangle PQR is similar to triangle XYZ. And there we go. Now this one, I have one angle involved. So K corresponds to O, but are the sides proportional? So let's look. 24 divided by 6, is that the same thing as 16 divided by 4? And the answer is yes. Those are also 4. So why are the triangles similar? By side angle side similarity. Similarity statement, I'm going to say triangle HJK is similar to triangle MNO. All right. And this is similar to what your homework is going to look like. So looking at these two triangles, I see this triangle and I see this one. Are they similar? Well, when we see parallel lines, we should automatically think alternate interior angles. So that means this is congruent to this, and this is congruent to this. And we don't need it, but remember vertical angles are also congruent. So, if that's the case, are they similar? Yes. By what reason? Angle similarity. And there's no scale factor though, because I don't have any side lengths. But this one, here's the two triangles. This one and this one. So for my green triangle, the sides are, this is 6. For my orange triangle, this is 4. And notice that these are the same. Okay, now I have that, as well as notice these are parallel, which means corresponding angles are also congruent. So it means this is congruent to this. So I have angle. So are they similar? Or angle side, I can use either one, but angle is enough. Or whoops. So are they similar? Yes. By what reason? Angle, angle. And the scale factor in this case is 4 to 6, which is 2 to 3 when you reduce it. All right. This one. Now, it does not say that they are parallel in this case. However, they do share that angle. So again, let's use, this is my red triangle, and this is my blue triangle. My red triangle this is 4 and this is 6. In my blue triangle, the whole side length here is 6, and this whole side length is 9. And remember, this angle is the same in both of them. It's the same angle for both. So it appears like we have side, angle, oops. Looks like a side, angle, side, side, angle, side. But we gotta check to see if they're proportional or not. 6 to 9, is that the same thing as 4 to 6? The answer is yes, it's 2/3. So are they similar? Yes. By what reason? Side, angle, side, similarity. Scale factor being 2/3. All right. Now this one, 2 triangles here as well. Use the orange one, and we have the green one. Orange triangle, 4 by 4 by 6, and the green one, another isosceles triangle, is 6 by 9. No angles, so we just need to see, are the sides proportional? So 4 is to 6, as 4 is to 6, as 6 is to 9. 4 is to 6, as 4 is to 6, 6 is to 9. See how those sides are proportional or corresponding to one another? And again, are all those proportional? The answer is yes, and it's a scale of 2/3 again. So similar, yes. By side, 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 similarity, scale factor being 2/3 again. All right, last page here. So looking at the triangles, we need to determine which ones are similar and then say why. So these, between triangle 1, 2, and 3, which ones are similar? So when I look at this, I know it has to be proportional by sides. So does 5 correspond to 2.5, 7 to 3.5, and 6 to 3? 5 to 2.5, 7 to 3.5, 6 to 3. Yes, those all equal 2. Therefore, triangle 1 is similar to triangle 2 by side, side, side similarity. 2 and 3 are not similar because 2.5 to 1 is not the same thing as 3.5 divided by 3. And same thing for why 1 and 3 doesn't work, because 5 divided by 1 is not the same thing as 7 divided by 3. Okay, this one. Looks like we have an angle involved. So side, angle, side, it looks like side, oh wait. Notice the angle is not between the two sides. So if any two triangles are similar, it's going to be side angle side here and side angle side here. Well, it's 3 to 30, the same thing as 5 to 55. So 3 divided by 30 is 1/10. 5 divided by 55 is 1/11. So are they similar? Are 4 and 6 similar? No. And 5 is not similar to either of them because the angle is in the wrong spot. So in this case, none of them are similar. Well, actually, I can just leave that. Okay. This one, looking at 7, 8, and 9, appears that for these two, for 7 and 8, I have 2 angles, whereas this one I only have 1. But maybe because that one's missing, but maybe I can prove it by side, side, side. So, because this one I have 2 angles and 2 angles, so 7, triangle 7 is similar to triangle 8 by side, side, side. And notice that 32 to 30 is not the same as 70 to 68. When you divide those out, those are not going to be the same. So it's going to be triangle 7 and triangle 8 by side, side, side. Last one's here. 10 and 12 both have angle, angle. So triangle 10 is similar to triangle 12 by angle, angle similarity. And now let's look at 11 and 13. Are those similar? 2 to 6 is the same thing as 3 to 9. However, notice the angle is in the wrong spot. Here, the angle is not between the two sides, but here it is. So even though the sides are proportional, the angle is actually in the wrong spot, so it's not side angle side. So in this case, only those two are similar. All right, that does it for 7.3. That should give you a good start on your homework. Let me know if you have any questions. Thanks.